They have announced their intentions very clearly that they want to add up to 30 gigawatts of capacity. Gigawatt capacity of all the hyperscalers combined is around that ballpark, 30 gigawatts. $1 billion deal with Microsoft. So when you look at it from that perspective, 38 billion is not that big. To use their own chips, it's just that they haven't had that kind of success that Google has had with TPUs. I think Google so far is ahead in that, but clearly Amazon is trying to catch up when it comes to their own chips. Running a cloud business, you're trying to optimize things across the stack.
The world's most powerful companies are secretly transforming farmland into something that will reshape civilization itself. What they're building consumes more electricity than entire cities, generates heat that could warm neighborhoods, and represents the largest infrastructure shift since the Industrial Revolution. This isn't science fiction. It's happening right now, and the implications are staggering. In a quiet Indiana town with just 1,900 residents, something extraordinary emerged from the cornfields. Where crops once grew, now stands a facility drawing 2 gigawatts of power, enough electricity to supply millions of homes. This single complex houses nearly a million AI processors, yet contains zero traditional GPUs. This radical departure from conventional wisdom either represents the smartest strategic move in modern computing or the most expensive mistake in corporate history.
The transformation began last December when Amazon selected this remote location for Project Rainier, an $11 billion AI supercluster that defied every established rule about building artificial intelligence infrastructure. While competitors scrambled to secure NVIDIA's latest chips, Amazon took a path that industry veterans considered impossible. They built one of Earth's largest AI facilities without a single GPU. This decision stems from a crisis few understand. The AI revolution has created an insatiable hunger for computational power, but the traditional approach has hit a wall. NVIDIA's dominance in AI chips created a bottleneck that threatens to strangle innovation. Their latest Blackwell GPUs require specialized packaging technology that only one facility in Taiwan can produce at scale. This single manufacturing step has become the choke point for the entire AI industry. The numbers reveal the severity of this constraint. A single high-performance AI server rack now costs $3 million. Lead times stretch beyond 6 months. Major tech companies find themselves not just buying chips, but locked into an entire ecosystem they cannot control. The situation has become so desperate that companies are hoarding chips like precious metals, creating artificial scarcity that drives prices even higher. Amazon recognized this vulnerability early. They understood that relying on external suppliers for critical infrastructure meant surrendering control of their AI destiny. Their solution was audacious: design and manufacture their own AI chips optimized specifically for their needs. The result is Trainium, a custom processor that breaks the GPU monopoly. These aren't merely alternative chips, they represent a fundamental rethinking of AI computation. While GPUs excel at versatility, handling everything from gaming to scientific simulations, Trainium focuses exclusively on training artificial intelligence models. This specialization allows Amazon to achieve something remarkable: comparable performance at half the cost, with 40% less energy consumption. The technical achievement is impressive, but the strategic implications are profound. By controlling their silicon destiny, Amazon can optimize every aspect of their AI infrastructure. They're not buying products. They're building an entire ecosystem tailored to their exact specifications. This vertical integration extends from the chips themselves to the cooling systems, networking infrastructure, and even the power generation. Power has become the ultimate constraint in this new world. Project Rainier's 2 gigawatt appetite equals the consumption of a major metropolitan area. In a town of 1,900 people, this single facility now dominates the entire regional power grid. The challenge isn't just securing electricity, it's maintaining perfect stability. AI processors don't draw power smoothly. They surge and drop in milliseconds, creating waves that can destabilize entire grids. Amazon's solution reveals how far they're willing to go. They've installed massive battery systems that act as shock absorbers, smoothing power fluctuations before they reach sensitive equipment. They've become energy developers, not just consumers, investing in power plants and renewable energy sources to secure reliable electricity. In Pennsylvania, they've gone even further, purchasing a data center directly connected to a nuclear power plant, guaranteeing access to 40% of its output.
They have announced their intentions very clearly that they want to add up to 30 gigawatts of capacity. Gigawatt capacity of all the hyperscalers combined is around that ballpark, 30 gigawatts. $1 billion deal with Microsoft. So when you look at it from that perspective, 38 billion is not that big.
The cooling challenge proves equally daunting. 2 gigawatts of power becomes 2 gigawatts of heat, enough thermal energy to overwhelm conventional cooling systems. Traditional data centers would consume millions of gallons of water daily, potentially draining local aquifers. Amazon chose a different path, designing systems that rely primarily on air cooling, using water only during the hottest hours of summer days. This decision reflects the impossible choices facing the industry. Water cooling is 30% more efficient, allowing denser computing configurations and lower energy use. But in drought-prone regions, consuming vast quantities of water creates community tensions and environmental concerns. Amazon's air cooling approach uses more electricity but preserves precious water resources, a trade-off with no perfect solution. The networking infrastructure presents another revolution. While NVIDIA's systems rely heavily on expensive optical connections, Amazon chose copper wiring for most internal connections. This seems counterintuitive. Optical networks offer superior bandwidth and elegant scaling, but copper provides something more valuable: simplicity, reliability, and dramatically lower costs. By accepting certain limitations, Amazon can build faster and cheaper, trading theoretical perfection for practical efficiency. None of this matters without customers, and here Amazon made their biggest bet. They've invested $8 billion in Anthropic, creators of the Claude AI models that compete directly with OpenAI's ChatGPT. This isn't just financial investment, it's a symbiotic relationship. Anthropic's models run on Amazon's Trainium chips, providing real-world validation and continuous feedback for improvement. The collaboration goes deeper than anyone realized. Trainium 3, Amazon's latest chip announced just days ago, was co-designed with Anthropic's engineers. The AI models shaped the silicon, and the silicon accelerates the models, a virtuous cycle that creates efficiencies impossible with off-the-shelf components.
Then they signed a deal with Google TPUs. So Anthropic and OpenAI are the purest plays when it comes to LLMs. And then Microsoft added Anthropic. So from that perspective, I can see why OpenAI wants to go to Amazon. We've grown to $500 billion in valuation this year. They started off the year at around $200 billion. Right now is through AI infrastructure, renting AI infrastructure, whether it's power or data center capacity.
This tight integration between hardware and software represents the future of AI development. The implications extend far beyond Amazon. Google pioneered this approach with their TPU chips, which power their Gemini models and attract customers like xAI and Meta. Microsoft is developing their own AI chips. Meta partners with Broadcom for custom silicon.
In the case of Meta, they are planning to spend over $100 billion in CapEx next year. And what they have promised to investors is they'll get to $100 billion in ARR by 2027, 2028. This $38 billion means they'll add $5 billion in revenue. That's how much OpenAI will end up paying Amazon. That's where the ROI question is the most obvious in the case of Meta, because obviously they keep raising their numbers. We will give them more AI functionality. Look at what OpenAI has done with AI generated content, which is why Amazon actually trails so far. It's only after their recent print that you got a lift in Amazon. And
the era of one-size-fits-all computing has ended. The future belongs to specialized systems optimized for specific workloads. This transformation is reshaping geography itself. Across America, Europe, and Asia, rural communities watch as tech giants transform their landscapes. Farmland that fed nations now feeds machines. Small towns find themselves hosting facilities that consume more power than major cities. The social contract between technology and society is being rewritten in real time. The financial dynamics create their own concerns. Big tech companies invest billions in AI startups, which spend those billions on compute from the same big tech companies. It's a circular flow of capital that generates impressive growth numbers but raises questions about sustainability. When does investment become dependency? When does innovation become mere financial engineering? Yet the momentum seems unstoppable. Amazon alone plans to invest over $100 billion in AI infrastructure in 2025. They're not just building data centers, they're creating a distributed computational grid spanning continents. Each facility represents a node in a planetary-scale thinking machine, connected by fiber optics and powered by everything from solar panels to nuclear reactors.
I mean, look, Amazon, we know, is the largest cloud provider with almost 50% share. And to use their own chips, it's just that they haven't had that kind of success that Google has had with TPUs. I think Google so far is ahead in that, but clearly Amazon is trying to catch up when it comes to their own chips. Running a cloud business, you're trying to optimize things across the stack. Their capex efficiency will be a much bigger focus in 2026 than it was in the past 2 years.
The winners in this new world won't be determined by who has the best AI models. Those can be copied or surpassed. Victory will go to those who secure the fundamental resources first: land near reliable power, access to cooling water, and most critically, the ability to turn raw electricity into computational power more efficiently than competitors. It's a race for the commanding heights of the AI economy. This shift from virtual to physical, from software to hardware, from algorithms to infrastructure, represents a profound change in how technology companies operate. They're no longer just writing code, they're pouring concrete, stringing power lines, and negotiating with utility companies. The cloud has come down to earth, and it's hungry for resources. What we're witnessing is nothing less than the birth of a new industrial age. Just as the first industrial revolution transformed agricultural societies into manufacturing powerhouses, this computational revolution is transforming manufacturing economies into something we don't yet have a name for. The factories of the future won't produce goods. They'll produce intelligence itself.
The story of Project Rainier and Amazon's billion-dollar bet on custom silicon is still being written. Whether Trainium proves superior to GPUs, whether the economics justify the investment, whether Anthropic's success validates the strategy, these questions remain unanswered. But one thing is certain: the age of computational abundance has begun, and with it comes challenges and opportunities we're only beginning to understand. The cornfields of Indiana have become the battleground for the future of human knowledge. Where farmers once worried about rainfall and soil conditions, engineers now monitor power loads and cooling efficiency. It's a strange new world, but perhaps not so different from the old one. We're still cultivation specialists, still tending our crops, still dependent on the land. We've just changed what we're growing. That's it for today, folks. See you in the next video.